Guys, today we'll be discussing on the history of the atomic theory. Now, whatever you see around are made up of some or the other entity, right? And that entity is nothing but an atom. Now, many scientists were very curious whether this atom that they have found, is it the last indivisible thing or is there something else to it? So, in this video, we'll be mapping out the history of the atomic theory and how it evolved over the history. The atomic theory has originated as a philosophical concept in the ancient India and Greece. And the word atom has been derived from the Greek word atomos, which means indivisible. It took around late 18th century for science to provide a concrete evidence for the existence of an atom. In 1789, Antony Lavoisier has proposed the law of conservation of mass, which states that the mass of the products in a reaction is equal to the mass of the reactants. And in this state, Joseph Louis Proust has proposed the law of definite proportions, which states that the masses of the elements in a compound always occur in the same proportion. Now, these two theories had no reference to atom, yet John Dalton has built upon them and developed the law of multiple proportions, which states that the ratio of masses in a compound always occur in whole numbers. Now, John Dalton's law of multiple proportion was based on the experimental data. Now, he said that the chemical element has a single type of atom which could not be destroyed by any chemical means. So his oral presentation in 1803 and his publication in 1805 marked the beginning of the scientific atomic theory. Alright, so up to this point, everyone believed that atom was the last indivisible thing that they could found, but not until 1897, because in this year, J.J. Thomson had discovered the electron in an atom, which made him believe that an atom was divisible. Now, because an electron carried negative charge, he proposed the watermelon model, where he said that the electron was embedded in a mass of positive charge, yielding a neutral atom. And then later came Ernest Rutherford, who was one of Thomson's students. Now, he disproved the watermelon model in 1909 by finding out that the positive charge of an atom and most of its mass is located at the center or the nucleus of an atom. He described a planetary model in which the electrons orbited a small positively charged nucleus. Now, Rutherford was on the right track. He knew what he was doing. But his model couldn't explain some of the factors like the absorption and emission spectra of an atom, nor it could explain why the electron did not crash into the nucleus when they were oppositely charged. So in 1913 comes the scientist Niels Bohr with his famous Bohr's model of atom, which is still the basic structure of the atom even today. His model stated that the electron revolves around the nucleus only at a specific distances. Now, according to his model, electrons couldn't spiral into the nucleus but could make quantum leaps to other energy levels. Now, Bohr's model explained the hydrogen spectra, that is, the absorption and the emission spectra of an atom with single electron. But his model couldn't extend that behavior to other atoms which had more than one electron. Later, Louis de Broglie proposed the wave nature of moving particles, which Schrödinger proved and described using his Schrödinger's equation in 1926. Now, this led to Werner Heisenberg's uncertainty principle, which states that it is impossible to know simultaneously both the position and the momentum of any particle. So this was the beginning of the quantum mechanics. People were trying to understand about this electron, which was smaller than the atom's size. So this led to the atomic theory, in which the atom consisted of smaller particles, like electrons. So the electron could be potentially located anywhere in an atom, but it was found with most probability in an atomic orbital or an energy level. So this was all about the history of the structure of the atom and how it evolved through the years.